How do you build a city on a world 140 million miles away? For decades, the dream of a human colony on Mars has been the stuff of science fiction, a grand vision hampered by insurmountable logistics, astronomical costs, and the sheer hostility of the red planet. Sending human construction crews is a perilous and inefficient fantasy. But what if the first builders on Mars aren't human at all? What if the architects are algorithms and the laborers are machines? Deep in the unforgiving expanse of the Nevada desert, a radical experiment is underway. Project Mars Base Alpha is not just building a habitat, it's building a new paradigm for interplanetary construction. Here, under the harsh sun, a new generation of autonomous robots, guided by a sophisticated artificial intelligence, is turning digital blueprints into physical reality. They are learning, adapting, and constructing a prototype habitat, a stepping stone for humanity's future among the stars. This is the story of how AI is not just accelerating a project, but accelerating a dream, laying the foundation for our first home on another world. One robotic arm and one calculated decision at a time, humanity stands at a precipice, gazing into the cosmic ocean. To remain on one world is to risk ultimate extinction, a single point of failure in a universe of untold dangers. This is the Martian imperative, the profound instinctual drive to ensure our species' survival by becoming multiplanetary. Mars, our silent red neighbor, offers that chance. Yet, the challenge is monumental. A journey of millions of miles, a landscape scarred by radiation under a thin atmosphere, and temperatures that plummet to unimaginable lows. Building a permanent, self-sustaining outpost, a true foothold for humanity, has long been the stuff of science fiction. Traditional construction methods reliant on shipping every nail and beam from Earth are impossibly slow and expensive. The sheer logistics would cripple any mission before it began. A paradigm shift was not just desired, it was essential for the dream to ever take shape. The problem demanded a solution as bold and visionary as the goal itself, a tool that could think, adapt, and build in a place where no human could easily labor. The call for a new kind of architect was sent out. Before we can build on Mars, we must first prove we can build on a world that pretends to be it. Welcome to the Ares Valley Proving Grounds, a remote and protected expanse in the Nevada desert. Its iron oxide-rich soil and arid, rocky terrain make it one of Earth's most convincing Martian analogs. Here, under a relentless sun, Project Mars Base Alpha was born. The initial team, a collection of the world's brightest engineers, geologists, and roboticists, arrived not to a finished facility, but to a windswept wilderness. Their first task was to establish a command center, a fragile human outpost in a landscape that tested their resolve daily. The fine, abrasive dust infiltrated everything, a constant reminder of the challenges Martian regolith would pose. The isolation was profound, the silence broken only by the wind and the crackle of radios. This crucible made the case for an autonomous solution, demanding a workforce that never tired, never breathed, and would never falter in the dust. In a climate-controlled server room, miles from the desert heat, a new kind of mind was awakening. It was codenamed Prometheus, an artificial intelligence designed not merely to follow instructions, but to comprehend, innovate, and overcome. Its genesis began with a colossal data ingestion. Petabytes of information flowed into its neural networks. The complete geological survey of Mars, thousands of architectural blueprints, material stress simulations, and the atmospheric data from every rover and orbiter ever sent to the red planet. The goal was to give it a complete understanding of the problem space. Dr. Eris Thorne, its chief architect, watched as the system went live. There was no single switch, but a cascade of processes, a hum of immense computational power. The team held its breath. Could a machine truly grasp the nuance of building a home for humans in an alien world? Could it anticipate problems it had never seen? The first sign of success was not a line of text, but a visual. It was not just processing data, it was actually thinking. The command from Prometheus was simple. Initiate Phase 1. At sunrise, the bay doors of the mobile assembly unit hissed open. A fleet of specialized rovers rolled out onto the red sand. These were not simple machines. They were the AI's hands, eyes, and tools, a swarm of autonomous architects. Each unit had a purpose: excavators, material printers, robotic welders, and assemblers. They moved with an eerie, coordinated grace, their paths optimized by the central AI to avoid collision and maximize efficiency. The first major test came quickly. An excavator, digging the foundation for the main habitat dome, hit a subterranean layer of unexpectedly dense caliche, a rock-hard deposit the initial surveys had missed. In a human-led project, this would mean hours of delay for analysis and replanning. For Prometheus, it was a data point. Within 3.7 seconds, the AI retasked the excavator, rerouted a second rover with a high-frequency sonic drill to assist, and simultaneously recalculated the foundation's load-bearing points, altering the blueprint in real time. The team in the command center watched, mesmerized. They weren't just observing robots, they were witnessing a new form of collaborative creation, a seamless fusion of digital intellect and physical action. After just 28 days of relentless, automated work, it was finished. Alpha Base stood against the rugged Nevada horizon, a vision of the future made real. Its interconnected geodesic domes, coated in a white, dust-repellent material, reflected the desert sun. Polished solar arrays tracked the sky, already generating more power than the habitat required. The moment of truth arrived as the project's lead engineers, clad in simulation spacesuits, cycled through the primary airlock. The hiss of pressurization was the sound of success. Inside, the air was cool and clean, the low hum of the life support system a comforting presence. Through the thick, radiation-shielded viewport, the familiar red desert looked utterly alien, a perfect simulation of a view from Mars. Mission Director Lena Petrova ran a gloved hand along the smooth, 3D-printed interior wall. This was more than a structure of metal and polymer. It was a testament to a new partnership between human ambition and machine intelligence. The blueprint had become reality. The Nevada sky, once a brilliant canvas of blue, turned a menacing shade of ochre. A sudden, unpredicted derecho slammed into the construction site with the force of a physical blow. Human crews scrambled for the safety of the command center, their work halted by nature's fury. But the project did not stop. This was the moment Dr. Eris Thorne, the AI's principal architect, had been waiting for. On his monitors, a digital consciousness came alive. The AI, named Daedalus, immediately began processing terabytes of real-time sensory data, wind shear, pressure differentials, and vibrational harmonics. It retasked every available drone, transforming them from builders into defenders. Robotic arms, which moments before were positioning habitat panels, now pivoted to brace structural weaknesses the AI predicted would fail. It was a symphony of automated survival, conducted by an algorithm. Daedalus rerouted power, sacrificed non-essential systems, and focused every watt on reinforcing the primary dome's integrity. In the control room, Thorne watched, breathless. The AI wasn't just following orders. It was improvising, adapting, and protecting its creation all on its own, a silent guardian against the storm's wrath. The blueprint had become a living, thinking entity. As the first rays of morning light broke across the horizon, they revealed a scene of surreal tranquility. The storm had passed. The Mars Base Alpha prototype stood silent and resolute. Project Director Lena Petrova led her team out of the command center, the air crisp and still. Anxious faces turned to expressions of astonishment. Not only had the structure survived the 100-mile-per-hour winds, but it was stronger. Daedalus had not just defended, it had learned. During the night, it had analyzed the storm's impact and recalibrated the entire next phase of construction, optimizing material usage and structural dynamics based on the real-world stress data. Lena walked to the main habitat dome and placed her gloved hand on its cool, metallic surface. It was more than just a successful test. It was a vindication. The fusion of human ambition and artificial intelligence had weathered the storm. This structure in the Nevada desert was no longer just a prototype. It was the first draft of humanity's first home on another world, a testament to a new partnership between creator and creation. A new frontier was not just on the horizon. Its foundations were already built here on Earth, waiting for the journey to the stars.